So last class, a power n u of n minus a power n u of minus n minus 1. Okay. And region of convergence concept we studied. Some more basic problems are available. Find the Z transform of sin omega naught n u of n. Not working. X of n equal to sin omega naught n u of n. Find the Z transform and its region of convergence. Okay. So formula for Z transform, summation x of n z power minus n. X of z equal to summation n equal to minus infinite to infinite. Standard formula, but sin omega n u of n is there. So u of n valid from 0 to infinite only, right? Now your summation limit changing from 0 to infinite. N from 0 to infinite. X of n equal to sin omega naught n. So sin omega naught n, I'm going to rewrite as sin theta equal to e power j theta minus e power minus j theta divided by 2j format. Okay. So write your sin omega naught n, e power j omega naught n minus e power minus j omega naught n divided by 2j into z power minus n. Okay. So 1 by 2j take outside commonly. Now summation n equal to 0 to infinite e power j omega naught n z power minus n minus summation n equal to 0 to infinite e power minus j omega naught n z power minus n. Okay. Next step, transform into a power n format. 1 divided by 2j summation n equal to 0 to infinite e power j omega naught into z power minus 1 whole power n minus summation n equal to 0 to infinite e power minus j omega naught and z power minus 1 whole power n. Okay. So summation 0 to infinite a power n format. So that we will write the result by using the formula 1 divided by 1 minus a. 1 minus e power j omega naught z power minus 1 minus 1 divided by 1 minus e power minus j omega naught z power minus 1. Okay. Now how to find ROC? So in this example, two terms are there. This is first one, summation 0 to infinite a power n. Summation 0 to infinite a power n. So I told you the region of convergence, how to get, equate this a term must be less than 1. So first term e power j omega naught is at inverse. E power j omega naught z power minus 1 less than 1. Okay. Or otherwise we can write it as e power j omega naught less than z, right? E power j omega divided by z, if you go right side, z. This is from first term. You know e power j omega naught modulus cos theta plus j sin theta, you'll get 1 only. And from the second term, e power j omega, e power minus j omega naught is at inverse. You will get the same result, right? E power minus j omega naught result also, you will get this relation only. Okay, so e power j theta equal to cos theta plus j sin theta, modulus meaning root of cos square theta plus sin square theta 1. So 1, or we can write it as z is greater than 1. The region of convergence for this particular problem, z is greater than 1. So further simplify this particular problem by cross multiplying this and solve it. You will get sine omega naught z power minus 1 divided by 1 minus 2 cos omega naught z power minus 1 plus z power minus 2. Let's cross multiply this term and denominator multiplication. Again simplify. E power j theta plus e power minus j theta equal to cos theta, e power j theta minus e power minus j theta equal to 2j sin theta, and simplify, you will get this answer. So modulus of z is greater than 1. Okay, so this is a z transform result of sin omega naught in u of n. Similarly, you may solve z transform of cos omega naught in u of n. Okay, replace sin theta cos theta into e power j theta format and substitute in the z transform main formula and reduce the equation 0 to infinite a power n format. Your result is 1 divided by 1 minus a. ROC modulus a less than 1. Okay, so z transform problems are very simple when compared with the Laplace transform. Finding ROC also very easy in z transform. Next problem, x of n equal to 2 by 3 power n u of n plus minus 1 by 2 power n u of n. Find z transform and find the region of convergence and plot it poles and zeros location. So what is the formula? A power n u of n z transform z divided by z minus a. ROC modulus z greater than a. Okay, so a power n u of n, directly write your result, z divided by z minus 2 by 3 plus second step z divided by z minus 1 by 2, so we'll get plus 1 by 2. Okay, ROC for this z is greater than 2 by 3. Second term ROC z is greater than minus 1 by 2. Okay, so if you draw the circle with radius minus 0.5, draw the circle with radius 0.5, both are same. That's why we are using this symbol modulus. Okay, now just cross multiply and write your final result. Z into z plus 1 by 2 plus z into z minus 2 by 3. Okay, z minus 2 by 3 z plus 1 by 2. So denominator no issue, the poles are directly available. Z equal to 2 by 3 and z equal to minus 1 by 2 poles. But numerator, again you have to simplify this. Z square minus 1 by 2 z plus z square minus 2 by 3 z, and then take z common, you will get 2z minus 1 by 6. Reduce the numerator. Okay. Now how many poles are there and how many zeros are there? Because in the question, plot poles and zeros first. Z equal to 0, numerator. Z equal to 0. Next, 2z minus 1 by 6 equal to 0. Then you will get z equal to 1 by 12. So from the numerator, the coefficient or the factors, factorize first and then equate to 0. You will get zeros. From the denominators, z equal to 2 by 3, z equal to minus 1 by 2. This is poles. Okay. So region of convergence, z greater than 2 by 3, and here also z greater than 1 by 2. So you can write region of convergence outside of outermost circle. So ROC Z is greater than 2 by 3. Okay. Both condition has to be satisfied. So we can select ROC outside of outermost pole. Now draw the Z plane and plot your poles and zeros and mention the region of convergence. X-axis, real part of Z. Y-axis, imaginary part of Z. Z equal to 0 at the origin. Z equal to 1 by 12. 2 zeros marked. Z equal to 2 by 3. Let us assume this is the point 2 by 3. Z equal to minus 1 by 2. Okay. So we have to draw a circle with 1 by 2 and draw the circle with 2 by 3. ROC greater than 1 by 2, greater than 2 by 3. Okay. I already mentioned you in Z transform, if two causal signals are given, the resultant region of convergence outside of outermost circle. Because your ROC should not include the poles. So if we show the region of convergence like this, it by default it satisfies Z is greater than minus 1 by 2 also. This is your region of convergence. Okay. In yesterday class, one causal signal, one non-causal signal mixed. U of n, U of minus n minus 1. Then how to show the ROC? By considering A less than B, A greater than B. Okay, if A value, B value given, then accordingly you can plot it. So in this example, both are causal signal. UN, UN. Two poles are there. Outside of outermost pole is your ROC. And similarly, many small problems are there. Find Z transform of del of n. I'll write down directly. Z transform of del of n. If you solve it, you will get value 1. Okay. Your ROC entire Z plane. And Z transform of U of n. If you find U of n, you will get Z divided by Z minus 1. Your ROC real part of S is greater than 1. Okay, these are some standard formula. And some more problem I'll list out. You try to practice. Due to insufficient time, we need to concentrate more on inverse Z transform. So suppose 1 by 2 power n u of minus n given. We know a power n u of n formula. But now 1 by 2 power n u of minus 1. So how to solve this problem? U of minus n zero, minus 1, minus 2, and so on, up to minus infinite, magnitude 1. So x of z equal to summation limit n equal to minus infinite to n equal to 0. 1 by 2 power n u of minus n magnitude 1 z power minus n. Next, minus infinite to 0. I need 0 to infinite actually. So can we replace n by minus n in the first step? So that minus n equal to minus infinite, minus n equal to 0, 1 by 2 power minus n z power n. So this is similar to n equal to infinite to n equal to 0, 1 by 2 power minus n z power n. So in the summation infinite to 0 is same as summation 0 to infinite. So 1 by 2 power minus 1, 1 by 2 power minus n is 2. Is z power n. Okay, this entire term I'm writing as 2 z power n. So 0 to infinite a power n. 0 to infinite a power n. I don't 1 divided by 1 minus a. Okay, so this is your result. Region of convergence, this a term must be less than 1. 2z, this term must be less than 1. Or z is less than 1 by 2. 2z, if 2 goes right side, 1 by 2 it is. Okay, so this is your result. X of z equal to, so if you want to convert this particular result in the form of z divided by z minus a format, something like that. So just multiply minus 0.5 on both numerator and denominator, or 1 by 2. So you'll get minus 0.5, so that this term will become z minus 0.5. ROC modulus z 1 by 2. Okay, so u of minus n. U of minus n. U of minus n is a non-causal signal. Your ROC less than a pole. Your ROC less than a pole. Modulus of z less than 1 by 2. Okay, causal signal meaning ROC outside the pole. Non-causal signal ROC inside the pole. More than one non-causal, your resultant ROC outside of outermost circle. More than one non-causal signal, your ROC is inside of innermost circle. Okay, so understand the basic concept. So whatever may be this problem given, apply your summation limit carefully, and finally transform your expression in the form of 0 to infinite a power n format. Okay. Next, what are the properties of Z transform? As usual, linearity property, time reversal property, time shifting property, convolution property, multiplication property. Okay. And additionally two, initial value theorem, final value theorem. In Laplace transform and Z transform, only in these two transformation technique only, the initial value theorem and final value theorem available. Okay, first property, linearity property. So this property we studied in all the transform technique. What linearity properties is? Suppose x1 of n, Z transform result is x1 of Z. x2 of n, Z transform result is x2 of Z. Then ax1 plus bx2, a, b are constant. Then your answer will be equal to ax1 of Z plus bx2 of Z. It's the linearity properties. Second one, time shifting property. So problems based on properties also may come. Time shifting property. Suppose x of n, Z transform representation is x of Z. X of n minus m, the result will be equal to Z minus m into x of z. This is time shifting property. Okay. If your signal is shifted by minus m amount of time, your result will be equal to Z power minus m into x of z. So based on this, we can solve the problem also. Example, I'll give you it parallelly. Find Z transform of a power n minus 1 into u of n minus 1. Nothing is mentioned, right? Using property or not using property, nothing mentioned. A power n minus 1, u of n minus 1. Find the Z transform. At this case, you can apply the time shifting property. Because we know a power n, u of n. Result is Z divided by Z minus a. Okay. Or 1 divided by 1 minus a Z inverse. Both are same. Now we have to find out Z transform of a power n minus 1, u of n minus 1. N is shifted by n minus m. Here m is 1. Okay. Now use the formula x of Z. Your final result will be equal to this value into z power minus 1. Using time shifting property, x of z equal to z power minus m minus 1 into z divided by z minus a. Okay, so it will be cancelled, 1 divided by z minus a. This is your result using time shifting property. So you have to identify whether that particular problem can solve directly with the help of Z transform formula or using any one appropriate properties of Z transform. Next property number 3, multiplication by exponential sequence. Multiplication by exponential sequence. A power n x of n. X of n Z transform x of z. A power n x of n. Your result is x of A inverse z. Okay. All these z's are replaced by A inverse z. So this is exponential sequence multiplication. Time reversal. So this is available in all transform. So what time reversal property? X of n, x of z. X of minus n is what? That is time reversal property. X of minus n result will be equal to x of z inverse. So wherever z is there, all the z replaced by z power minus 1. Okay. Next, differentiation property or multiplication by n. Both are same. Differentiation in frequency domain or multiplication by n. Let's consider x of n is a transform x of z. N into x of n. N into x of n result is minus z d by dz of x of z. Okay. Or differentiation in frequency domain property. X of n, x of z. N x of n result is minus z d by dz of x of z. One example I will give you. Find Z transform of x of n equal to n into u of n. Okay. What is u of n? Z transform result z divided by z minus 1. Okay. So now n into u of n. N into x of n minus z d by dz of x of n. So Z transform of n into u of n equal to minus z d by dz of x of z. X of z of u of n z divided by z minus 1. Okay. So differentiate with the help of u by v formula and simplify it. So we'll get z divided by z minus 1 first. Just an example how to use this property. Differentiation in frequency domain. And next one, convolution property. Same concept. Fourier transform, Laplace transform, DTFT in Z transform. Convolution property. What convolution properties is? Suppose x1 of n convolving with x2 of n, convolving with x3 of n, and so on. If you apply the Z transform, the result will be equal to x1 of Z multiplication with x2 of Z. Understand? Convolution in time domain, multiplication in frequency domain. It's a convolution property. So using convolution property, we can find the inverse Z transform. So example we studied in DTFT also, Laplace transform and Fourier transform. In all the transformation, we discussed one example for the convolution problem. Okay. Finding convolution between these two signals using Z transform. Find x1 of Z, x2 of Z, multiply together. Now if you apply the inverse Z transform of this using partial fractional method, you will get convolution result between x1 of n and x2 of n. Okay. So these are some important property in Z transform. And next one, initial value theorem. Initial value theorem in Z transform. That is, initial value of a signal can be obtained from its Z transform. That is, limit Z tends to infinite x of Z. So this is initial value theorem. Similarly, final value theorem. X of infinite equal to limit Z tend to 1 Z minus 1 into x of Z. Initial value theorem and final value theorem of Z transform. Okay. In Laplace transform also initial value theorem, final value theorem available. What is the meaning of this theorem? Suppose x of n signal is it. To find what is the initial value at n equal to 0 of the signal, that we can calculate from the given Z transform of that signal. Similarly, what is the value of the signal at n equal to infinite, that can be obtained from the given Z transform of that particular signal. Okay. So example for final value theorem. Example for final value theorem I am giving. In Laplace transform also we solve some problem. While applying the final value theorem concept, we have to check some condition. Right? Do you remember in Laplace transform? In Laplace transform, if any poles lies right half, then final value theorem unable to apply. Okay. In Z transform, final value theorem applicable only all the poles are lies within unity circle. What is unity circle? The circle with the radius 1 in the Z plane. Real part of Z, imaginary part of Z. If all the poles of Z minus 1 x of Z term lies inside this unity circle. Inside this unity circle, then only we can apply the final value theorem. Okay. So there is a theory behind that, which is not required for you at BTech level. So remember this concept. Final value theorem, you have to check whether all the poles are lies within the unity circle or not. If all the poles are lies within the unity circle, then the system is stable system. Similarly, in Laplace transform, if all the poles are lies left half of S plane, then the system is stable system. Okay. Here it is inside the unity circle, then the system is stable system. First example, find x of infinite. First example, x of z equal to z plus 2 divided by z minus 0.8 square. Okay. So how many poles are there? Z equal to 0.8, 2 times z equal to 0.8. So 0.8 is lies within this unity circle, right? Yes. Okay. Now we can proceed for the final value theorem. So x of infinite equal to limit z tends to 1, z minus 1, z plus 2, z minus 0.8 square. First check is there is any possibility for cancellation of this z minus 1. In this example, not possible. So anyway, finally we have to substitute z 10 to 1. So 1 minus 1, 0. 0 multiplied with anything, 0 value. Second problem, x of z equal to z plus 1, 3 z minus 1, z plus 0.9. Find final value of the signal x of n from x of z. So limit z 10 to 1, z minus 1, z plus 1 divided by 3 z minus 1, z plus 0.9. First check whether is it possibility to cancel this term. Yes. Fine. And also, before applying this final value theorem, okay, fine. In this step only we have to apply. Cancel this z minus 1, z minus 1. So previously this z minus 1 unable to cancel. Okay. First one, fine, right. Second one, try to cancel this z minus 1. Okay. So rest of the term, limit z tends to 1. Okay. So z plus 1 divided by 3 z plus 0.9. So at this stage, check whether the poles are lies outside the unity circle or inside the unity circle. So z equal to minus 0.9. That is lies inside the unity circle. Okay. So therefore, the final value theorem valid. Substitute z equal to 1. 1 plus 1, 2 divided by 1 plus 0.9. And you'll get around 0.3508. Okay. Initial value theorem, no issue. Okay. You directly proceed the formula. But final value theorem, you must check. All the poles are lies within the unity circle or outside the unity circle. 3z plus 4, z minus 1, z plus 1. Find x of infinite. Limit z tends to 1, z minus 1, 3z plus 4, z minus 1, z plus 1. Cancel. Okay, but rest of the term z plus 1. Z plus 1, that is z equal to minus 1, pole. This is exactly, it lies on the unity circle. Okay, in that case also, this formula is invalid. Okay, so write down z minus 1 x of z as a pole on the unity circle. On the unity circle represents the radius of the circle is 1. Z equal to minus 1, right? Z equal to minus 1, either z equal to minus 1 or z equal to 1. Anyway, your radius is same, right? Radius of the circle. So if any pole on the unity circle also, this formula is invalid. So x of infinite is not defined. Okay. Just few problems using final value theorem. So basic problems of Z transform and some problems, formulas del of n, u of n, a power n u of n minus a power n u of minus n minus 1. So all are standard problems, formulas. We'll be using those formula in inverse Z transform. Okay. So inverse is a transform there, and I think we will cover the difference equation solving in today's class. Okay. Discrete time LTE system. How to solve discrete time LTE system difference equations with the help of Z transform. So in DTFT, I already taught you that DTLTA system. Consider a DTLTA system. Input x of n, output y of n. Impulse response represented by h of n. Okay. Z transform representation x of z, h of z, y of z. So the transfer function of the LTE system h of z equal to y of z divided by x of z, right? Or y of z equal to x of z into h of z. Because in time domain y of n equal to x of n convolution with h of n, LTE system output. In frequency domain y of z equal to x of z multiplication with h of z. There are some fundamental relation between input, outputs and its transformation. Okay. So now the problems. So I hope you can solve it. The transfer function h of z, impulse response. Impulse response meaning h of n. How to obtain h of n? So if you find the inverse transform of h of z, you will get h of n. Suppose you want to calculate y of n for the given x of n, h of n. Then inverse is a transform of y of z. Suppose y of n, h of n given. You want to calculate x of n. Then z inverse of x of z. Because the relation is available here. H equal to y by x. From this you may calculate y equal to h x, or x equal to y by h, right? So you follow that. And I'll solve some typical example on that. Plot the pole zero pattern and determine whether the following systems are stable or not. A discrete time LTE system, characteristics defined by the difference equation y of n equal to y of n minus 1 minus 0.5 y of n minus 2 plus x of n plus x of n minus 1. The LTE system described by this difference equation. Okay. Now comment on its stability, whether the system is stable or not. And find the transfer function. Transfer function meaning h of z equal to y by x. And plot poles and zeros. You know how to plot it. Okay. I'll write down. Stable system. How to find out stability of the system with the help of Z transform. Please remember h of z. Find h of z first. Transfer function. For the h of z, all poles must lie inside the unity circle. Inside the unity circle. Then only the system is stable. Remember this hint. So there is a theory behind this. From that theory, stability criterion theory, so we have derived finally to identify a system is stable or not from the given difference equation of the LTE system. The condition is we have to find out h of z, then check all the poles of h of z must lies inside the unity circle. What do you mean by unity circle? In the z plane, the circle with the radius of 1. This is unity circle. Right? So let us find h of z first. Apply the z transform of the signal. Y of z. Y of n minus 1 using time shifting property. Z transform z power minus 1 y of z minus 0.5 z power minus 2 y of z plus x of z plus z power minus 1 x of z. Next step, separate y term, x term. Y of z 1 minus z inverse minus plus 0.5 z power minus 2. Okay. X of z 1 plus z power minus 1. So transfer function h of z equal to y of z divided by x of z. So 1 plus z power minus 1 divided by 1 minus z power minus 1 plus 0.5 z power minus 2. Okay. Now you have to factorize this. Then only we will come to know how many poles are there, whether poles are lies within the unity circle or outside the unity circle. we can check. So h of z equal to 1 plus z power minus 1 divided by 1 minus z power minus 1 plus 0.5 z power minus 2. So what is the higher order here? Z power minus 2 maximum. So multiply z square on both sides. Okay. So you will get z square plus z. Numerator. Denominator z square minus z plus 0.5. Okay. So take one z outside, z plus 1. So zeros are ready now. Z equal to 0, z equal to minus 1. Two zeros are there. Poles. Z square minus z plus 0.5. So multiplication of two number must be 0.5, addition of two number must be minus 1. So such numbers are not possible. You can use a quadratic equation to solve this. Minus b plus or minus root of b square minus 4ac divided by 2a. So using this relationship, find the roots of the denominator. You will get z minus 0.5 minus j 0.5. Z minus 0.5 plus j 0.5. So this is the roots of your denominator. Okay. So any problem given, to find stability, to find transfer function, this is your result. Up to this, your result is over. Then to find the impulse response, take inverse Z transform of this. You will get it, impulse response. But in the question, plot poles and zeros and check whether the system is stable or not. So numerator, Z equal to 0. Z plus 1 equal to 0. Therefore, Z equal to minus 1. So Z 0 and Z equal to minus 1. Zeros. Poles. Z1. 0.5 plus j 0.5. Z2. 0.5 minus j 0.5. Two poles. How to plot it in a Z domain now? These poles and zeros. Real part of Z. Imaginary part of Z, right? So zeros. Z equal to 0. Z equal to minus 1. Right? Poles. 0.5 plus j 0.5. Let us assume this is 0.5. 0.5 minus plus j 0.5, this point. Let us assume this is j 0.5 and this is 0.5. 0.5 minus j 0.5. Okay. This is the pole 0 location. To find stability of the system, we must draw a circle with the radius of 1. Okay. Draw a circle with the radius of 1. Let us synthesis. I am not drawing the circle with a radius of zeros. Okay, don't remember that. Generally, we have to draw a unity circle with the radius of 1. This circle I'm going to draw it now. So draw it carefully. Let assume, sorry, okay, with the radius r equal to 1, unity circle. Okay, so all the poles, two poles are there. All these two poles are lies within the unity circle only. Write down. All the poles lies within the unity circle. Therefore, the given LTE system is stable system. Okay. How to identify whether the given LTE system is stable or not? This is the procedure. If any poles lies on the unity circle also, it is unstable. Please remember that. Have to do carefully. All the poles must lies within the unity circle. One pole lies inside the unity circle, but another pole lies outside the unity circle. Then it is unstable. Suppose poles are lies on the unity circle and stable. Okay. So I think within this one problem, I covered many things. One is how to find transfer function or frequency response. Second thing, how to plot poles and zero. And next one, how to identify stability of the system. Okay. So similarly, to take this problem as your homework, try to solve in the same manner and check whether the given LTE system is stable or not. Y of n equal to 1.8 y of n minus 1 minus 0.72 y of n minus 2 plus x of n plus 0.5 x of n minus 1. Okay. Try to solve this problem and identify whether your LTE system is stable or not by checking the poles. Verify your result. So after applying Z transform, separating your y of z, x of z, your transfer function expression is z plus 0.5 divided by z minus 1.2, z minus 1.6. Is it stable system or unstable system?
Unstable, sir.
Yes, the system is unstable system because z equal to 1.2. 1.2 is outside of the unity circle. Even z minus 1 is there. In that case also you have to write a pole is on the unity circle. Therefore, the system is unstable system. Okay. One small problem I want to cover now. Please adjust so that tomorrow we will start inverse is a transform directly. Okay. So beginning of the class, we wrote the expression for relationship between DTFT and Z transform. Okay. Relationship between DTFT and Z transform. What is the condition for DTFT to be exist? DTFT, we can apply DTFT of a discrete time signal based on some condition only. That is n equal to minus infinite to infinite, x of n must be less than infinite. So this is nothing but a stable system, stable signal. Then only we can go with DTFT. Similar concept like your Fourier transform, CTFT. To analyze unstable signals and all, then we go for Laplace transform in time domain signals and Z transform in discrete time domain. Continuous time Laplace transform, discrete time domain Z transform. So formula for DTFT, h of e power j omega equal to h of n e power minus j omega n, where n varies from minus infinite to infinite. Z transform. H of z equal to summation x of n z power minus 1. N varies from minus infinite to infinite. This is Z transform formula. I told you Z is equal to R e power j omega. R is the radius of the circle. If R equal to 1, if R equal to 1, usually h of R e power j omega equal to summation x of n R e power j omega. Power n. If R equal to 1, we can reduce this expression. Z transform derived from DTFT only by assuming Z equal to R e power j omega. N equal to minus infinite to infinite. N equal to minus infinite to infinite. X of n R power n into e power minus j omega n. Now compare this Z transform with DTFT. Almost same, except this R power n, correct? Check this. H of n e power j omega n. Or x of n e power j omega n. Here also x of n e power j minus j omega n. Extra term is R power n. So in Z transform, R power n multiplied with a signal, and then we are taking the DTFT of the signal. This is nothing but DTFT of a signal multiplied with R power n. Then you will get your Z transform. For R equal to 1, now your formula x of e power j omega, your Z transform formula, x of e power j omega equal to n minus infinite to infinite, x of n e power minus j omega n. So at R equal to 1, your DTFT is same as your Z transform. If you replace Z by R e power j omega. Okay. So that is h of e power j omega can be obtained from h of z. If z equal, by replacing z equal to e power j omega. Okay. This is very important relationship. So we have a problem using this property. I'll write down clearly. for h of e power j omega to exist, the ROC of h of z must include sorry okay h of z must include the unity circle. Okay. Or otherwise since region of convergence cannot contain any pole, cannot contain any poles of h of z. So all the poles must lie inside the unity circle. Okay, I'll explain to you. So what is the statement? From the given x of z, we may directly calculate h of e power j omega. Sorry, h of z to h of e power j omega. When if all the poles are lies inside the unity circle. So that is the meaning. Okay. That is stable signal. That is your given signal is a stable signal. I think you can understand in better way if you solve some problem related with this statement. X of z provided z divided by z minus 0.5 z plus 0.7. Find the DTFT of the following signal. So by looking at this question in your semester question paper, don't get afraid. X of z given, but find the DTFT of the or find the DTFT. Then how to do it? Usually x of n given, we calculate DTFT, right? Or x of n given, we may calculate x of z. But x of z, that is z transform of a sequence x of n given. But we have to write the answer for DTFT. How? That is what we discussed so far. X of e power j omega is equal to x of z when r equal to 1. Or otherwise, how to check this? Check the poles of your h of z. If all the poles are lies inside the unity circle, then you can replace z by e power j omega. Okay. Solution for this. Z equal to 0.5 and minus 0.7, right? Poles. All the poles of x of z lies inside the unity circle. All lies inside the unity circle. Now we can calculate DTFT. Therefore, x of e power j omega equal to e power j omega. Replace all z by e power j omega. E power j omega minus 0.5. E power j omega plus 0.7. Okay. CTFT Laplace transform, both are same for the stable signals. Same concept here. DTFT and Z transform of a signal is same for the stable signal condition only. So this we will complete this today lecture. X of Z equal to Z divided by Z plus 1.2, Z plus 0.7. Okay. Find DTFT. Find DTFT of the sequence. Sequence not given first of all. The transform of the sequence only given. Poles. First point you have to check the poles. Z1 equal to minus 1.2. Z2 equal to minus 0.7. So can we find DTFT from the given X of Z? From this basic information? Just respond. What is the condition I told you? X of Z to X of e power j omega can be done if provided all the poles of X of Z lies inside the unity circle. So here pole lies outside the unity circle. Therefore, DTFT cannot obtain directly. From given X of Z. So read the question paper carefully in your mid exam, in semester exam. Okay. Blindly don't replace Z by e power j omega. X of Z to X of e power j omega conversion possible only if all the poles lies inside the unity circle. That meaning if the signal is a stable signal. First of all, we are going for Z transform and Laplace transform for analyzing unstable signals in system only, with some condition, that condition called as region of convergence.